Hello, everyone. Welcome to ITRL Webinars. Today, we have a very special session. We call it the Roundtable edition of ITRL Webinars. It's something new that we are trying, and I'm pretty sure it'll turn out really, really wonderful because we have something really special lined up for you. But before we begin, I just want to give you the general instructions that please keep your microphone and camera turned off. And if you wish to ask any questions, please use the raise hand or the chat feature. But I would ask you to keep all of your questions reserved for the discussion part of the seminar so that all our presenters will just finish presenting everything and then you could take part in the discussion section. Before I introduce the seminar, we have these webinars coming up pretty soon. Please check our ITRL website or our social media pages and subscribe for the newsletters to get more updated information. We have some really exciting new seminars that we are planning to have in the next semester. So yeah, please sign up. And now, today we have a really wonderful group of speakers and the hosts and moderator talking to us about the research that they've been doing with sustainable integrated urban freight for the HITS project, which ITRL is also part of. And I will let Peter do a little more introduction in a bit, but the best part of this is that we have our wonderful experts who would be sitting at this roundtable, and there'll be a lot of back and forth discussion between the speakers' perspectives, the ideas for the project, as well as some reflections as well. Just quickly with the agenda, we'll have Peter and Elizabeth giving us an opening perspective, after which each of the presenters will have their perspectives. And then we'll have a little break somewhere around 2 o'clock. So let's hope that we stick to our time schedules. And towards the end, we have the roundtable session. And during that session, we'll first have a discussion between the speakers and the experts. And then there'll be some time for you guys to ask your questions. Meanwhile, if you have any burning questions and you can't hold it in, please use the chat feature and type in all of your questions. And I'm sure one of the speakers would definitely find their way to answer your questions. So with that, Peter, the floor is all yours.
Thank you, Bana. All right, my name is Peter Georén, and I'm acting as research coordinator in the project of HITS. So we are studying sustainable integrated freight in the urban setting. We're doing this project for a year now, and I think it's a good opportunity to start sharing the knowledge that has been created within the research, the academic research field. So we have the speakers today, but before we go into the knowledge sharing, I've asked Elisabeth Hörnfeldt, who is project manager for entire project, to give a first introduction to what HITS is all about. So we'll start from the broad perspective. And I welcome Elisabeth up on stage. I will be sharing the slides and Elisabeth will be on audio presenting. So it's a bit of a challenge. So
Thank you.
Let me try to share my screen, and the stage is yours, Elisabeth.
Thank you, Peter.
And I'll tell you when I have the screen sharing functional. Hang on a second.
I don't see nothing yet, but I can present myself. So my name is Elisabeth Hörnfeldt. I work at Scania. In Scania, I work at the department that calls Innovation Office or Research and Innovation Office. And I'm proud to be the project leader of this project. I'm also acting head of the Innovation Office at the moment. And it has been a real challenge and a real joy to be project leader for this project that has now ongoing for a little bit more than a year, I should say. We started up in the very first phase of the corona pandemic, so it was a challenging start in the beginning. I don't see any slides, Peter, but so anyway, don't lose time. I think you can listen in to me and see this nice picture going around and around. And anyway, we have a clear vision for this project is to look in how can we create sustainable transport in the system. In the transport system of urban logistics, I should say. So it's not all transporters, it's focusing on urban logistics, and we will focus on the city transport urban logistics. So we have tried to be focused on that one, and we are trying to see how can we do this then in a sustainable way. So what we really would like to do and to dig in and to solve is that we think that there is many cars that goes into the cities today, and we see a strong trend of downsizing in cars. And I think due to Corona, we have seen even more cars running around in city deliver. And the main goal of the system logistics today is to decrease the window of from where you order to when you got the package or things. That is not, however, maybe the case for all business to business transport. But if you look at from a customer to business perspective, I think most of the logistics system would like to narrow down the window between ordering and delivering, meaning they have not changed much in that system. It's ends up just more cars. So if we can just think differently and change a bit in the system that we see today, can we have more efficient flows? Can we have more packaging going on a bigger vehicle, and can we distribute the last mile more smart than we did before? That is one of the challenges we would like to address. I think one of the enabler of making things different than it is today is the digitalization that is ongoing, and during this last year it had been a really rapid change. So we have focused really much on the hypothesis thinking, can we share data between actors? And if we can, what can we do with the data? Can we create a transparent system that actually can lead to efficiency in the system? That is another part. And we also believe if you could set that seamless information between partners in the system, then you can give efficiency. It also will have a big impact on the transport need coming into the city. So you will have a positive gain in the whole logistics system if you also can solve the last meter on the last mile, so to say, delivery. Could that also be the case? So I think HITS is trying with different methods to see, in a way, how can digitalization and how can new vehicles enter to town, solving the problems that we see today with congestion and bad air and contribution to climate in a better and a smarter way, without losing the focus on the customer needs that we see is an improvement factor, that we are getting more and more spoiled is maybe not the right word, but we are more and more interesting to really have personalized services. That is a strong trend that we would like to meet as well. But we also think that personalizing could be in the perspective that we actually can make choices from an environmental point of view. And could that happen? Could we then decide upon how we should transport our goods? So that is one of the framework, I should say, for HITS. Thank you, Peter. I'm sorry for all this messy situation with the pictures and everything. I hope it's everything sold out anyway. It became good in the end, I hope.
Thanks so much, Elizabeth and Peter. I think, Claudia, I think you should go. If you have to stick to a break time.
Yes, sorry for all the disturbance.
Thank you so much. Then I would like to introduce Claudia, first presenter of Research Aspects, just to cover up some time. Claudia, the stage is yours.
Yes, can you all see my screen? Yes, thank you. So good afternoon, and thank you for the short introduction, Peter. So my name is Claudia. I'm a PhD student in the HITS project. And today I will present to you briefly the work that I have carried out so far, that it's on the understanding the impacts of concepts on the urban logistics system. So starting from the project vision, which is to understand and create conditions for such a system, I am looking more in specific at the system effects and design of such a sustainable urban logistics system. And the main research question that I am exploring is, how do concepts for urban logistics contribute to a sustainable urban logistics system? And I look at this question from a system level perspective. So from this very broad research question, I have three main areas that I want to explore, and these are sustainability with the related question, how can sustainable performance be assessed in urban logistics? But also modeling. So how can we model such a system, and also impacts. So what are the impacts of different concepts on the urban logistics system? And to answer these three research questions, I work with three main methodologies, and these are literature studies, which are needed to understand the system of urban logistics and have a clear picture of what the problem is. But also system dynamics modeling, which I would say it's my main methodology or the core methodology of my work, because system thinking is very important to understand the system level effects, for example, of different concepts. And this is key when we are looking at the sustainability of the system, as we are doing in the HITS project. And then we're also aiming at using some group model building, which involves stakeholders and relevant actors in the system, and involving them when building the model and when developing scenarios. But today I will present you the results of my first task, which was a literature review on sustainable urban logistics systems that was done to answer the first research question through a systematic literature review. So the first part of the aim of this work was to carry out a literature review, to analyze the existing literature on logistic concepts. And this is also done to understand to what extent different concepts are mentioned in the literature. Then from this literature, we selected some relevant papers that have key performance indicators or such assessment methodologies. And we selected from a huge pool of candidates, we selected some key performance indicators that we want to use for sustainability performance assessment. And with this key performance indicator, we aim then to analyze the sustainability impact of different concepts on the urban logistics system. So now let's start with the first part of the aim. And we have here some results from this literature analysis. I've performed a search on the Scopus database, spanning from year 2008 to year 2020 on sustainable urban logistics. And I've collected over 1,400 papers, and we see here the evolution of the number of papers over time. Then we've classified the papers based on different tags, and these are year of publication, but also nation of provenance, journal or conference of publication, and what are the most explored concepts. And then we've categorized them based on the performance, so the number of papers, but also the impact, the average citations of such papers. And here we can see an example of our results. So for example, categorizing them based on the nation of provenance, we can see here on the x-axis, the average citation per paper, which is the impact of such groups, and the number of papers on the y-axis. And we can see that Sweden is positioned with a quite high impact, but a rather low number of papers. And here we have what are the top 5 explored concepts in this literature review. Electrification is the one with the highest number of papers. Cargo bikes is the one with the highest impact. But then we also have automation, consolidation, and vehicle routing. Then moving on to the second part of the aim, which was the selection of the key performance indicator, I have followed the methodology depicted here on the slides. So I have first selected 19 papers through a search, so looking for papers with key performance indicators or impact assessment papers. And in these 19 papers, I found over 70 KPI candidates. This is how I call them. And for each of the candidate indicator, I followed this sequence of steps. So first, I checked whether the candidate is, you can define it clearly. And then I checked whether one could measure this indicator and assign it a unit. Then I also checked whether it is possible to measure this KPI at the concept level. And the indicator is not a system level indicator. And one example of a KPI that has been discarded in step number 5 is mode share. So mode share is a characteristic of the system, and it cannot be applied to a single concept. So it's been discarded at this stage. Then I've also performed some aggregations because we want to we didn't want to have a large number of KPIs. And we came up with 16 selected KPIs that then has been categorized according to two axes. One is the sustainability axis and one is the system level axis. In the sustainability axis, we have environment, society, and economic perspectives, while in the system level axis, we have societal and organizational perspectives. On this system level axis, we could have also added the user perspective, but in this case, it has been considered as integrated in the societal perspective. And then we've put it together visually in the form of a matrix. And now I'm going to go through the KPIs that I selected. So in the environmental perspective, we have CO2 emissions that want to represent the overall life cycle of the product used, for example, to deliver the service, but also air quality, which instead represents the quality of the air locally in the urban environment. And then we have the operational energy consumption that has been chosen from an organizational level. And this is stands for the operational efficiency that actually affects the environment. In the societal category, we have accidents, noise, and average parking time, and this has been selected to represent the conflict level that there is between the actors in the city logistics system and the citizens living in the city. Then we've also added customer coverage. From an organizational level, we here have working conditions, which is a measure of the percentage of companies that have active union agreements. In the economic perspective, is an example. So here is an example of how such an evaluation would look like, and this is just a preliminary result for now. And here I have suggested a scale of impacts, so from negative to a negative impact to positive to a positive impact, and this has to be understood as the impact of a concept on the KPI. So, for example, for CO2 emission, it doesn't mean that the KPI decreases to have a negative impact. So for example, for CO2 emissions, the KPI would decrease. If the KPI decreases, we would have a positive impact. So one needs to understand what the direction is. But here is the example of urban consolidation centers. So I've based this on 12 papers that are cited right here on the slide. And we can see that, for example, we have a positive impact on CO2 emissions and air quality, and positive impact on a lot of KPIs from the economic and organizational level. But we do have as a drawback the infrastructure cost. And we do not know whether, like these papers, we're not agreeing on whether it has a positive or negative effect on congestion. And we see that some of the KPIs are not mentioned, at least in these papers, as impacts of urban consolidation centers. So this was my last result slide. So in summary, I have reviewed the literature on sustainable urban logistics. I have analyzed it and I've presented here a part of the results. And from the literature, I've taken 19 papers that discuss sustainability assessment to create a framework for sustainability assessment that contains both sustainability perspectives and system level perspectives. And I aim to use this framework to analyze the sustainability impact of the concepts. And this is still a work in progress. And this work connects back to the project vision, especially on providing knowledge for understanding what sustainable transport look like and what impacts we could expect from some of the concepts developed in the project on the urban logistics system. And here's my email. Contact me if you want to know more. And I hand back over to Petter.
Thank you, Claudia. That was really, really interesting to see. We will move on from your beautiful presentation and go a little bit into more details. So I introduce the next speaker, Jonas. Please join us and present your results, which is related to the modeling and optimization of the transport itself.
Yes, thank you, Petter. I hope you can see the slides.
Yes.
And you can also hear me, but I assume, yeah. Okay, Yes, my name is Jonas Hatzenbühle. I'm a PhD student at the Department for Transport Planning at KTH, and I'm going to talk a bit more, as Peter already said, about more technical detailed about potential sequential consolidation of passenger and freight transport has in urban environments. To kind of connect it to the overall project vision, my work is kind of focusing around the delivery from a hub towards the city center, or a central redistribution in the central area of a city. And that is done, at least in my work, with the help of a new technology, a new vehicle type, which is these kind of vehicles, which are multi-purpose vehicles. And that's how the sequentiality can be explained. So at one point in time, vehicles can be used to transport freight items, then modules can be exchanged to another module, and then at the new point in time, it is used to transport waste, passengers, or other things, right? So it can change the purpose over time, these type of vehicles. And the hypothesis now in this study I'm presenting is that we have two different flows. We have passenger and freight flow, and they follow a certain distribution. Typically, passenger peak are in the morning and in the afternoon, and freight might peak in the afternoon or in the evening, or most of the case, it's actually during the day. We have a lot of freight deliveries in the city, and with smart strategic changing now of this purpose of the vehicles, we might be able to reduce the fleet size and increase the utilization. So that's kind of the hypothesis of this work. And we can ask these research questions: how does this now impact the demand flow for the different stakeholders? How is the experience for this kind of new technology in the delivery process? Does it lead to a more sustainable transportation, urban logistics system, similar as Claudia has presented? The different KPIs can be applied, and then also how are customers affected? People who would be transported with that, or also customers expecting deliveries. How is the level of service for them affected by this new technology? So to give you a better understanding of actually what's happening in my work, I made a short illustrative example. So we have one depot here in the middle, and we have two freight items which should be delivered at a certain point of time. At the same time, we also have a passenger who would like to be picked up at this point and dropped off at that point. If we have now conventional vehicles, a solution could look like this. We have one vehicle operating as a bus, just as we know it, driving to pick up the passenger and returning to the depot. And then we would need a second vehicle doing the freight deliveries. Just to make sure that the pickup and drop-off times are respected, it could look like this. So if we sum up the solution, we would need two vehicles. We have, of course, no module changes, and we would have empty time. That's the time these vehicles would drive empty out from the depot or back to the depot, of around 2 hours in this particular case. Now, if we switch to the exact same problem, add service depots. So that's places in the city where modules could be exchanged. So we change the purpose of the vehicle with the new vehicle technology. A solution could look like this. We start our trip again at the depot. We deliver that first package in time. We then visit one of the service depots, exchange the module, and then continue driving as a bus, return to the depot, and switch again to then deliver the last package. So what we have achieved now with this kind of modularity is that we could reduce the total vehicle fleet size from 2 to 1, of course, at the cost of exchanging the module twice and also having the modules available at the depots, of course. And at the same time, we could also reduce the empty time. So overall, the utilization of the vehicles, if you can't compute it as empty time, is increased in this dummy scenario here. So some theoretical advantages, and that's what I wanted to highlight from this case, is that we could see a reduction of fleet size and a reduction of empty time using multi-purpose vehicles. Now, to solve this kind of question in a more systematic way on larger problems, real problems, we have produced an extension of the existing vehicle routing problems to facilitate the extra characteristics of this multi-purpose operation. We rate different solutions for this routing problem with two cost terms. So we respect the user cost as a combination of passenger travel time waiting time for passengers and freight items. And also the operator cost is computed as considering the fleet size, the total kilometers traveled, and the module exchange costs, of course. Any unserved demand is considered as additional cost for the system. The system is kind of designed or described using two decision variables within the optimization progress. First one is about time. So when is each customer served? When is a depot being departed, basically? So this is decided. And the second one is regarding the routing. Where is each vehicle at what, in what configuration driving around? So with these two decision variables, we can fully describe the system. And to shape kind of the characteristics of this special case, we have additional constraints. We have range constraints for the vehicle, capacity constraints for the vehicle, time windows for the requests, and some other constraints which shape this special flow and module exchange type, which make this problem unique. Unfortunately for us, this is a fairly hard combinatorial optimization problem to solve. It's actually NP hard, so it's very tough to solve it in time on large problems. So therefore, we have developed an own meta-heuristic optimization algorithm to solve this problem, which is adaptive large neighborhood search. And just for the people who are not very familiar with how that works, I give a very brief overview of how we still try to find high quality solution for large scale problems using this algorithm. So in the first step of this algorithm, we create a feasible solution. A feasible solution could look something like this. We start at the depot, we pick up one passenger, we pick up another passenger, we drop that passenger off, we drop it off again. Then we visit a service depot, we pick up a third request, could be a freight item, we drop that off again and visit the depot. So this is kind of, this sequence describes a solution, right? Now, if we have the solution in the next step of this algorithm, we destroy it again. That could be done by randomly taking one of the requests and just removing it from the solution, right? So then we have some kind of half-complete solution and the unserved customer. In the next step, we repair that solution again. So that means we take the broken solution and insert that customer request, which is missing, again into the solution. And now there are different ways of doing that. One would be inserted in the best possible way so that the objective, the user costs and operator costs are minimized. If you have done that, the fourth step is then to evaluate the two different solutions. First, the initial one we had and this new one. And then we pick, of course, the better one. We take the one with the lower objective value. And this is one iteration. We do these steps 2, 3, and 4. They get in detail, they're a bit more sophisticated, but in principle, that's how it works. We do these tens of thousands of times until we don't find a better solution or until the computation time is up. And then as the last step, we analyze the best solution we have gained so far. In our model, we also do quite some assumptions. One of them make it more realistic. One of them make it a bit more simple to solve this problem, actually. So the first assumption we have is that we model soft time windows. That means that if a passenger or a freight item is delivered a bit after the expected time or after the expected time, it is assigned a higher cost penalty. You can see it's a linear increase. So the further away from the expected time, delivery time, the higher this request will be penalized. So it's not the optimal solution. If we arrive a bit earlier, we still penalize it, but not as much as we arrive too late. For departure times, we have decided now that they are not as important. So therefore, we don't penalize late or early departures for now. We also assume a constant vehicle speed. All vehicles drive the same speed all the time. That makes the problem much easier. We also assume that all these vehicles can operate on the road network. So they are not necessarily driven autonomously, but that could be also something we could explore in the future. For now, they are electric, humanly driven vehicles. Then one thing which is important is how we model the exchange, the extra cost of exchanging the modules. And that is done by assuming there are 2 workers required at each service depot, which handle basically the exchange of that module. And that's the additional cost for that. The last 2 assumptions are considering the operation of the vehicle itself. So we say that the vehicle size, the vehicle range, the vehicle costs, fixed cost, operational costs are exactly the same for these new multi-purpose vehicles as for conventional vehicles. The reason for doing that is that we are in this study now only interested how is the different type of operation, just this sequential and modularity affecting the transportation system, not anything else like having bigger or smaller vehicles. So we have created 3 different case studies, which I will briefly go over. The first case study is described as we have freight deliveries in the city center of Stockholm. This is where the freight items should be dropped and delivered. We have passenger demand randomly spread in a larger area of Stockholm area. And we have 2 depots positioned outside of Stockholm. In blue are the service depots positioned at strategic positions in that area of interest. We also have a distributed scenario where freight is also randomly distributed over the entire area of interest. Everything else stays basically the same. Also, the passenger demand is randomly spread over. And the last point or last scenario is when we have clusters. This kind of should imitate or could be a scenario where operators decide we only want to serve a certain area of the city, and maybe there are different operators sharing different areas of the city. So therefore, which clusters to choose, and one for one operator, it would look like we're serving specific clusters, is then, in that case, even then, multi-purpose vehicle beneficial. Now, if you look at the results, now I briefly go over them. We have the 3 different scenarios here, and we have the conventional solutions here, very briefly summarized, and some of the interesting aspects for the multi-purpose vehicle summarized at the bottom. If we look closely, we see mainly 2 things. One thing we can see is that for conventional vehicles, we need 6 vehicles, and 10 vehicles for the respective scenarios. And for the multi-purpose vehicle, we need 6 vehicles plus 2 module change, 5 vehicles plus 2 module change, 8 vehicles for plus 3 module changes. So first, the hypothesis we had at the beginning seems to be holding true, at least in some scenarios, that we can reduce the vehicle fleet size at the cost of additional module changes. At the same time, however, if you look at the last column, we see that the total vehicle kilometers traveled are in all cases higher. So if we have now the perspective of an operator, we have kind of the trade-off. We can reduce the vehicle fleet by adjusting the modularity, but at the same time, the vehicles travel longer distances, which makes it more expensive to operate such a service. If you look at the passenger perspective, we have the passenger waiting time in this row here. I only gave qualitative comparison to not make too many numbers on the slides. So, but we see in general, or not in general, but in some scenarios, we can actually lower the waiting time for passengers. So it's actually better than in the conventional case. But at the same time, we have in some scenarios higher in-vehicle times, which means the travel times will be longer. Only in the centralized case, when you have kind of isolated passenger and freight flows, then passengers really benefit. They get lower waiting time and lower in-vehicle times. The operators kind of are worse off. In the cluster case, it's the opposite. Here, passengers suffer. They have higher waiting times and higher in-vehicle time than in the conventional case. And somehow in between lays the distributed. They again have a trade-off. On one side, you have lower waiting times for the passengers. On the other side, related to the higher vehicle kilometers traveled, you have higher in-vehicle times. So it's interesting to see the differences between the scenarios. And that's kind of also one of the takeaways, one of the conclusions now. If we come back to the initial research questions I had, that what is the impact of this multi-purpose consolidating for the different stakeholders? Then we have to say, if we just look at the costs, there's not much change, right? There's similar costs for conventional systems, considering users and operators, as in this new futuristic scenario. However, there is a trade-off in there. And if we look at if it could be more sustainable, that's one of the trade-offs we have to make and maybe analyze a bit more in the future is, does the smaller fleet size really give a better system considering longer routes? Or is it the longer routes outweighing basically the reduction of the fleet size? And the third part, considering the customer and the level of service for them, there, if I looked a bit more into the actual numbers and not just the quantitative results, we could see that the passengers are in general better off. So there is lower waiting times and they outweigh the slight increase in vehicle time. So for passengers, it seems to be actually a better system. Now, to kind of tie it back to the overall scope of the project and what are future directions we could do, one of the things which is interesting is look at different mode of operations, meaning we could include into the optimization framework also the delivery towards the hub and start optimizing this urban logistics system already one step earlier than just the last mile deliveries. Another aspect, if we look into multiple operator consolidations, meaning that what about data sharing between different operators? And can we then use one fleet for multiple operators, which kind of share requests between operators? That would certainly also increase the efficiency of this proposed system. And lastly, what I saw in the analysis in the study we have done is that the position of the depot and the size of the depot, also this new service depots, is quite crucial for the impact or the efficiency of this new system. So that's certainly interesting to also look into where and how large should these depots be in the city. So with that, I finish my presentation and thank you for your attention.
It's very interesting stuff. Much thanks. I hope there will be questions later on this topic. It's quite interesting. We keep moving on, so we just keep the pace high. And I would like to introduce Annette, to talk about the digital data possibilities. Let's call it that. All right.
Yes, let's call it that for now. I will present the actual title in, just hang on, share my screen here. Ta-da. See, and
yes, it's perfect.
Yes, I want to preferably see some faces also, you know, if something happens. Oh, maybe skip that for now. So my name is Annette Hultåker. I am a guest researcher at ITRL for 1 year. I normally work at Scania as a senior data scientist at Scania IT. And I only started this work now during the spring, so it's quite new. And what I'm going to talk about is towards a data sharing ecosystem for a case of coordinated distribution of goods and the advanced benefits that might bring about. And let's also here start in the project vision. As Elizabeth mentioned in the introduction, data is a crucial part and actually sort of the foundation for this. If we're going to accomplish this, we need data. And many of the new concepts derived within HITS also rely on additional data sharing between various actors. So data and analytics is basically a very big part, and that comes up in the various work packages within the HITS project. What I'm going to cover here is sort of first set a little bit of foundation around transportational data, and then look at benefits of data sharing, both in general and then later on in terms of when it comes to transportational data, barriers for sharing data, and remedies towards these barriers or obstacles. Go back to the project vision again. Talking about transportational data, this might be very familiar ground for some of you, but I want to stress this in a way that this can be a very broad set of data. We have both what is called structured data, which is usually quite fairly easy to handle, shipment orders, vehicle IDs, goods IDs, with lots of various attributes, sensor data, but it can also be unstructured data in terms of text, video, sounds. And looking at the picture below, what could this mean here? Well, of course, then goods data, we have fleet data, vehicle data, but it could also mean public organizational data like traffic controls, toll station, passenger statistics, or what's not. And third-party data like weather data, road data, maps, and so on. What can we then do when we have the data in more in general terms? How do we refine data and make something out of it? So here's a pyramid that illustrates how we gradually upwards refine the data that enables more advanced decision support and also personalization. So at the bottom layer, we have raw data. If you think, for example, sensor data doesn't usually very useful in itself. It needs to be processed a little bit, perhaps normalized, standardized, categorized, linked with various data sources and indexed, just to mention a few things. And then creating the mid layer, where we can start to draw conclusions, see the current status of our system. If we move further up, we have predictive analytics, where we can try to forecast what will happen. And at the top, more prescriptive or even AI system that are self-decisive and decides for us, very highly customized. But as we move up this pyramid, this also puts additional demands on the data, and I want to highlight that one as well. We can say that we have at least 6 basic demands: completeness, quality, quantity, accessibility, connectivity, or as we refer to it sometimes, interoperability, and validity. And which one that is most important depends on the application situation. We have, for example, as you will see later, here worked more with actually getting access to the data and being able to connect it. But later on, when we want to create benefits out of it and have solved these, then validity might be an important thing to dig into if we want to detect deviations in a normally well-ordered flow, but that things might go wrong and we want to detect them before something goes really wrong. If we then look at the barriers for sharing data, what could that be? I've here divided them into 3 different classes. The first one is cultural and organizational barriers. For example, that we don't see potential benefits. We have a lack of trust between actors in the system, fear of competition. We have the second class of legal and regulatory barriers, for example, restrictions on data location, uncertainty around the lawful grounds to use or share data for a specific purpose, uncertainty around the ownership or the data access. And last but not least, and which is very much my focus in this work, the technical and operational barriers, lack of interoperability, lack of standards, or simply high costs for creating data to be able to share it. And what is normally seen in this kind of work is that barriers might both be perceived or real. But luckily, there are lots of different remedies for overcoming these barriers, and I've listed some of them here. They many times sort of solve several problems in one go. So they're listed in no particular order here, but we have everything from sort of anonymizing data, share what can be shared but will hold sensitive data, typically costs or any kind of personal information. Aggregate data, just as Telia has done with our mobile phone data during the COVID to track where people are moving around. Creating synthetic data, not sharing the actual data, but sharing the important statistical properties. Cloud technology that provides sort of a read-only. You don't hand away the data. You can your counterpart can only read it. When we go to AI applications, you can train your models locally without sharing the data, but sharing the results of the training. This is referred to as federated learning. And of course, also working on the software issues, creating trust, for example, through closer collaborations. And then setting up suitable platforms and with that also creating additional benefits, as I showed with the pyramids. So there's something in there for the actors, which creates an incentive to share the data. And we can also think about regulating things with an agreement, which Christina Andersson will talk about more later. But I want to dig into these two now a little bit, about secure platform and create shareholder benefits. And what I show you now is a draft of what such a platform might look like. And it consists of several different parts, where the darker green ones are sort of data management tools that is needed to create this secure environment where you have control. And then you can add analytical capabilities within this. So you have on the left-hand side, data flowing in from various actors, being processed in various ways, can be displayed, can be shared back to others in a secure way with various kinds of restrictions, or further utilized for visualization, reporting, AI applications, and so on. And I've also added some demands or dimensions of the platforms that might be important for various stakeholders. Could be scalability, reliability, the toolbox in there, the ownership, the location in terms of cloud on-prem and geolocation. And now, during the last few minutes, let me then apply this on the one of the HITS use cases, which is the return coordinated distribution of goods case, which is 8 municipalities that have agreed on a coordinated distribution of goods to all their premises, typically children daycare centers, schools, and retirement homes. And what this picture shows, I apologize for the Swedish, is you have the customer at the foundation, and how information in terms of dotted line flows into a purchasing system and up to the supplier. And here we have the distribution center at the sort of the center of the picture. And we also have physical, sort of the flows of physical goods from the supplier down to the distribution center back to the customer. And as you can see, there's several flows of data going about here. And one thing that we have done here is that we have identified a number of benefits or gains in this particular case, and I'm showing just a few selected here, and then map them in terms of development time, scale, and feasibility. So everything from starting sort of in the middle of the triangle that I showed before with daily reporting, just what is here now, seeing the order in terms of order transparency, up to more advanced algorithms that can detect deviations or improve route planning or improve forecasting in various ways. So what we have done is we have set up a cloud-based platform on this and added this analytical capability and started sharing some of the data, far from all data so far. And we have also worked with, we have met some of the barriers and tried to overcome them. And I have a little bit of list here. It's not fully overcome. And I should also say that usually every time you need to bring in a new data source or a new actor, you meet many of the barriers again and again. So it's not sort of a one-time solution for many of these. In some cases it is. So we have, for example, worked with the issue of lack of trust and fear of competition, and seen what data should we perhaps withhold. Worked with the data location, the interoperability and standards for sharing. And also work quite a lot with the uncertainty in the lawful grounds and tackle that. And that is what Christina Andersson will talk more about in her talk after the break. So I leave on that note to sort of a little bit of cliffhanger for you to continue with afterwards. That
Perfect.
was all for me.
Perfect. Thank you, Annette. That was great. It's really interesting in material sharing. I think now we will go into a short coffee break, or break, if you will. And I can already now tease you that we will have Christina Andersson speak about the legal aspects after the break. But right now we do a 5-minute break. See you in 5 minutes. Okay, I welcome everybody back to the break, from the break. We are about to go into the next presentation of this research seminar. Looks good.
Okay, fine to go. Perfect. Thanks for inviting me. I'm a senior researcher at RISE, and I'm a lawyer as well. So my research field in Scania, his project is legislation. And when we started this project, we very early on realized that data was interrupted all the time, and that business need to start collecting data all over again and again and again. And if we want to have a sustainable data sharing system within logistics, we need to somehow fix this and start sharing data with each other. So that's why we all started. How can we share data more with each other? How can we trust each other? How could it be safe? So we started looking into the legislation behind data sharing and logistics. And so the question was to share or not to share. So that's what we looked into. And I think most of you are not lawyers, so this is a quite shallow introduction. I won't deep into it, but I'm happy to answer any questions that you have. And when we talk about data sharing, you need to think of two different things. One is, with whom am I sharing data with? It could be business to consumers, or business to government, or business to business, or business to platform. And of course, consumer to consumer as well. But in this project, we have focused on business, how business share data. And to describe the structure of the legislation behind data sharing, is very much an incomplete system. You have horizontal regulation and you have vertical regulation. And horizontal regulation, that is something that applies to everyone, all industries. And for example, Gdpr is a horizontal regulation that applies to everyone. But then there's a vertical regulation that applies to a specific industry, for example, vehicle manufacturing or logistics or banking. But as you can see, it's a very much an incomplete system with many gaps. And this is something debated. Is it good or is it bad to have all this gap and an incomplete system? And I will share you some knowledge what we have learned from the project about these boxes. So I will move on to, this is about horizontal regulations that applies to everyone, but we really need to look into this project. And of course, the first one is Gdpr, that you all know about. And in the Scania HITS project, we have some minor issue with Gdpr when it comes to live streaming data, but they're quite manageable. But you also need, because we are dealing with Södertörn and they are municipal, it's about food distribution. And we have legislation about sharing data that could be interesting for an enemy, like the evil Russians or a terrorist or something like that. So you shouldn't share every data. You should save some data, so to say. And Södertörn, they have cleared the data in this project. It's safe to share the data with us. They are not showing too much information about food distribution, for example. And then we have data about camera surveillance, but we don't have cameras yet in this project, so that might be a future topic. I will change slide to, we are still on horizontal regulation, but this applies to agencies. And as I told you before, Södertörn is an agency, it's 7 municipals. And they have this offentlighet och sekretess, publicity and secrecy law. And so far in Sweden, most data is open, but Södertörn, they have chosen, for example, not to share information with us about the price on goods. So we don't get every data from them. And then there's another legislation that is public sector information. That is on European Union level, there's a wish for more data from agencies to be open data and shared free on platforms. So this is a strong driving force when you're dealing with agencies, but they should share more data. And the next one is not so important in our project yet. We are more targeting governments, but maybe when it comes to EU Cybersecurity Act, we will be standardizing about how to share data secure with each other. I'll go to the next one. It's horizontal regulation about data sharing still, but applies to business. And EU, they have a regulation on platform to business, and it's much about fair trade and what is a term to enter a platform, how is the price regulated and so on. And maybe we'll do a platform in our program. So we need to look into that, the platform legislation. And then there's two legislation about trade secrets and legislation about copyright. When it comes to data sharing, it's quite tricky to protect your data. Actually, legislation is not protecting your data that well. And that maybe is one reason why it's so hard to share data, because you feel you're not comfortable by sharing your data because you're not sure what happened to the data when you have shared it. And then you have a last one is competition law. And competition law is about data that you actually want to share, but shall not share. Because if you share data with a competitor, you can very soon run into a price cartel, for example. So it's easier to share data vertical, but it's very tricky to share data horizontal. So this is something that we need to keep track in our project. Who are we sharing data with within the ecosystem? I go on to the next one. Now I will change. Now we are on the vertical regulation. And in this project, there isn't much vertical regulation that we need to look into. There is a regulation about tobacco, food, and medicine, about their data sharing. And tobacco is more to make sure that tax are paid for tobacco. But food and medicine, they have actually interesting way of sharing data. It's two different solutions. It's all about safety. Food, it's they share data in links in a chain. So you share the data with you received your food from and the one you're giving away the food to. Medicine, they have chose a completely different system. It's very centralized. You can think of it as a wheel, so to say, or a star, but it's centralized. It's one point that all the data are collected in, and then it's distributed down the system. And then there's intelligent transport system that collects data from vehicle. It's about road safety and traffic safety. It's about the congestion data, for example, or accidents. And then we have the last one. It's legislation about vehicles to make sure that they follow legislation. We have legislation about tachograph, about rest and work time. We had legislation about sharing data with third-party garage. That is to make sure that we have a free competition between garage. And we have legislation about sharing emission data. And that is to make sure that we have a good climate in the future.
You tried to wrap up?
Yes. So this is my conclusion. There is not much regulated by law, which open up for letting agreement control data sharing, and agreement is controlled by business models. And the question is, will it stay like this? There's lots of things going on European Union level, but might fill up the gaps that I talked earlier about. But right now, all these white boxes, they are like open opportunities to share data, and you're free to decide yourself how to do it. But that was my summary. So thank you very much from me.
Thank you, Christina. Really interesting work. I'm glad that you have covered all the legal aspects, and there's much to think about and take into account when we go forward. And I would like to invite the last speaker, which is Tim. He will be presenting a very interesting topic, looking at the collaboration on this level and how that works. The floor is yours, Tim.
Thank you. Thank you, Peter. Can you see my presentation?
Yes.
Awesome. Hello, everyone. My name is Tim Salimi. I'm a PhD student at the Integrated Product Development and Design Unit here at KDH. And within HITS, I look at collaborative innovation and design. And this, in the last 2 increments, we've been looking at multi-stakeholder insights from off-peak deliveries. Let's see. So I'm going to also start with the project vision. And as we have said repeatedly, the project vision is to understand and create conditions for a sustainable transport system in the city. Now, our research field connects closely to that in the sense of we're looking at design experiments and methods for collaborative future making and servitizations to explore, prototype, and understand conditions for sustainable integrated transport systems in the city. So it's the work that goes beforehand. And we're looking at collaboration, innovation, servitization, and business model change. So just to give you a quick insight at off-peak deliveries, there have been many projects and pilots on off-peak deliveries, which pretty much means delivering at off-peak times. It's pretty self-explanatory. So between 10 o'clock and 5 in the morning. Usually within Europe, it's forbidden to drive in the inner city with heavy trucks during that time because of noise pollution and safety concerns. And in off-peak deliveries, we use these trucks that are qualified as off-peak to emit very little noise, but also operate on electric mode as soon as they enter the city through the use of geofencing that the previous speakers talked about. So we have been looking at off-peak deliveries conducted within HITS 2024, and we have done interviews. And the motivation for this has been that the results from off-peak deliveries has shown that even though the pilots have had a decrease in CO2 emissions and an increase in transport efficiency, this initial exploration has failed to get new receivers to join the program. And also there has been a lack of motivation for the receiving companies. So the companies ordering food or whatever it might be to receive at nighttime. And we wanted to look at what are some of the problems and barriers resulting in this. So for this phase, we have created 3 research questions. What are the pain points and the gain points within off-peak deliveries? So the cooperation between providers and receivers. How is value spread within off-peak deliveries, and how are off-peak deliveries motivated? And third, what are possible barriers for collaboration within off-peak deliveries? So the research method has, for collaboration, we have done semi-constructed interviews looking at collaboration, values, and innovation. And then cooperation, we have used journey mapping to see routines, pain points, gain points, and how the providers and the receivers conduct their day-to-day business in cooperation with each other. So our focus has been, we have conducted a total of 17 semi-constructed interviews, and they have all been conducted within off-peak deliveries, focusing at different stakeholders. So we have had 6 providers. For clarification, providers are the transport companies delivering goods. Receivers can be different businesses, whether they're restaurants, institutions, but in this case, most of them are restaurants. 2 property owners, and potential receivers. So those are receivers that have been in contact with the providers to deliver goods, but for some reasons, they have failed to come to an agreement to actually conduct those. And we have talked to 1 regulator and 1 OEM company producing off-peak certified vehicles. Let's see. So in the cooperation, we have conducted journey maps, as said, and we have focused at pre-delivery, delivery, on the roads, on the site, and post-delivery. We have stacked all the journey maps and created a heat map of pains and gains. And some of the pains that have been identified have been initial investment costs are too high, and they're pain points for many companies. Transportation desks are not operational at night times, and they leave drivers unsupported. Operational issues with obtaining keys, codes, and access to delivery points. Driver safety might not remains a continuous concern. Night work salary cost remains a prohibiting factor for the receiver. Noise pollution, noise levels cause continuous concern in certain areas and result in legal complaints. Getting access to locations has been a big issue with many discussions with clients relating to locks, alarms, safety, insurance, and so on. And off-peak certified technologies wear off quicker than anticipated and result in increased noise. When it comes to the gains, off-peak certified trucks can operate 24/7, resulting in the fleets to shrink. Delivery of goods during nighttime saves time as trucks are not stuck in traffic. The driver experiences less stress. Benefit from off-peak deliveries outweigh the nighttime costs for the providers, not necessarily receivers. The silent truck creates a better working environment for the drivers. Transportation can be more precise, effective, sustainable, and there is less interactions with the citizens, customers, and city lives, so less logistical barriers. Deliveries are most off time due to lack of traffic, and clients were able in some cases to change their schedule, so receivers in this case, to accommodate for nighttime deliveries and also make saves by having their staff come in later. Okay, value mapping. So we have identified 3 motivations for off-peak deliveries. One of them is called, we call off-peak deliveries, and that is freight transport between 10 and 6 in the morning in the inner city of Stockholm using off-peak certified vehicles and support gear to ensure low sound emissions and geofencing to ensure the operation in electric mode and restricted areas as defined by Stockholm Stad. The deliveries are both manned and unmanned at the receiver stage. Then we have congestion-free deliveries, which are deliveries done at similar times to off-peak times to avoid congestion and wait in traffic and loading terminals. Those deliveries are most often unmanned and do not always use off-peak certified vehicles. Freight transport, and then we have unmanned deliveries. Freight transport without employees required at the receiver stage. Those locations are usually located in industrial zones, outskirts of the city, and they are not always conducted at off-peak times and also not with off-peak certified vehicles. If we go back to the value mapping, we can see that the unmanned deliveries are mostly very integrated, and usually they are done in-house with a shipping company just taking goods from the warehouse of the receiver to the supermarket of the receiver or whatever it might be. When it comes to off-peak deliveries, there is a lot of pain points in relation to city life, neighborhood complaints, workers' unions complaints about the worker safety, and congestion-free deliveries are usually very smooth with some issues raising around the driver safety and the general noise complaints as well. Okay. When it comes to the barriers that we have identified for collaboration within off-peak deliveries, we have seen that there was an unwillingness to share risk and reward. There was a lack of information sharing in general, and there seemed to be a lack of trust among the partners. Also, we have looked at some unaligned technological capabilities among partners and lack of collaborative and strategic planning. Also, a lack of supply chain vision and understanding between partners. And the operational licenses. So if you want to deliver at nighttime, you need an exemption from the city, and it is only linked to one truck, and you can only apply for it 1 year at a time, which results in a lot of uncertainty when it comes to investment in off-peak certified trucks and similar technologies. I can get into these later during the questions, if there is any. So next steps, the idea is to continue investigating collaborative barriers in HITS 2024 at large. When we say at large, we mean work package 3. So looking within hubs and transportation in general within HITS, and then going towards design experiments, prototypes, and workshops for overcoming collaborative barriers, which is a whole new set of activities that we plan to do within our field of work, which goes towards collaboration, innovation, servitization, and business model change. Thank you for your attention.
Thank you, Tim. There's a lot of information in there. It's really a good situation that we have a good time for questions now.
Yeah.
Appreciate your presentation. So now we will move into a panel discussion to have some experts having some questions and discussion about the presentations and see what we come up with. And then at the end of the roundtable, we'll also be able to pick a few questions from the audience. So please state your questions in the chat. I've already taken down some notes on the questions that has been there. But I now would like to introduce the experts to the roundtable. So Michael, Sönke, and Maria, please join the stage. And I recommend that you start, maybe Michael, if you start with a very short introduction of yourself,
Sure,
then Sönke, and then Maria, and then we go back to having a first question discussion.
Thank you very much, Peter. I'm Michael Brown. I'm at the University of Gothenburg working on urban freight questions, mainly from a policy side and policy business interface with the decisions that are made. So all very interesting work. Thanks.
Okay, Sönke. All right, I'm sorry we can't hear you, Sönke. So if you have, you can take some time to try to fix it, and we'll introduce Maria. Please give a short background, Maria.
Yes, hello everybody, and thank you for a very inspiring seminar. It's so full of interesting stuff. My name is Maria Hugebrodin. I work as a professor of logistics in Linköping, of green logistics, that is. So I have been studying many aspects of that topic, of which city logistics or urban logistics is one. So I'm very interested in listening to you and also going on with the discussion. So thank you.
Let's give Sönke another try if you are there now, Sönke. Try to see if we can hear you now and give a short background of yourself. So give another try, Sönke.
Yeah, okay, now I can hear you again. Can you hear me as well?
Yes, perfect.
Great, sorry for that. I know what it is with this advanced equipment. It's not very reliable. Okay, yes, my name is Sönke Beretz. I'm currently working at SSPA, which is a maritime research institution, but I previously worked at IVL, and this is also why I'm a part of this project. So it was good that I could continue working with HITS when I changed work earlier this year. So I'm a consultant still in the project for IVL right now. And yeah, my part of the project is also I'm working in work package, what was it? 4 or 3, I don't know, but it's about hubs. So I'm actively working in the project as well.
Yeah, and you've been around in the logistics field for a long time, Sönke, as well.
Yes.
Yeah, okay. Then we all know our expert panel, and I would like you to take a question, one question at a time, and we rotate. So I would please ask Mike to start if you have any thoughts, reflections, or questions you want to pose to the presenters.
Sure, maybe just a very short comment then, because I think just to echo what Maria said, I think it's a wonderful set of presentations, really interesting mixture of topics being covered, and kind of a nice way of having different approaches, but in a sense showing us how we need all this kind of interdisciplinary work or cross-disciplinary somewhere if we're to address some of these problems. So in some of these areas I feel on safe ground and quite familiar. In other areas I think, well, I'm not sure, this is not familiar territory to me. So the way to handle the routing problem, sure, I can ask questions about it, but it's not something I wrestle with on a day-to-day basis, for example.
Yeah.
So really good to do that, and quite hard to decide where to start with the questions, but perhaps because Claudia, if you're the first presenter, you often don't get the questions because everybody gives them to the last presentation. So I will start with Claudia's presentation as it was the first, and just to make one comment and then have a question. The comment's very short. It's about using citations as a way to count things. I think it's quite interesting. Obviously, highly cited articles are, there's something about them. They can also sometimes be highly cited because people disagree with them, which can be sort of an interesting thing to think about. That doesn't apply in the ones that you've looked at, I don't think, but it's just to be a little wary about citations. And the second with citations is that I think we have clusters of researchers who cite not their own work, but you get this kind of, I'm not sure it's circularity, but I know that if we move outside the freight area, cycle research gets a lot of high citations because there's some very active researchers who are looking at each other's work and then citing a lot of it. And so you get sort of interesting effects with citations. But my question was more at the end point where you had the kind of preliminary assessment of what was happening, and you had the three areas, the social, economic, and environmental, and then you had the organizational level and the sort of the broader level. My question was that some of the things are obviously very interconnected, so that if you have a vehicle kilometers traveled reduction, you get a CO2 saving, but then the way that the papers are framing it, they don't always comment on the fuel saving for the operator. So how will you address this sort of interconnectedness of that sort of last bit of assessment?
Yeah, I think it's a really interesting question. So thank you very much. And thank you also for the comment on the citations. I think that it's been very hard to actually categorize these KPIs and to choose the KPIs in a way that we could still have a very high overview, but we wanted to feel like we didn't miss anything. So it was very hard to find a balance between these two, like very specific or very high level. According to the comment on like how can we manage this interconnected KPIs, I think that what is important from my perspective is that we don't exclude anything and that we consider all the KPIs. And I don't want to, the result at the end doesn't want to be a comparison between two concepts saying this is better than the other. It's more where can we see a good impact of this concept and where can we see a less good impact, and then compare it to another concept, and then perhaps find a solution where we have a combination of concepts that can be connected together.
Yeah, that's great. And I noted that in your comment that you made in the chat thing about the way of blending these different things together. And I think that step will be very interesting and very important and very difficult. And I appreciate the difficulty of doing what you already did. So thank you very much, Claudia.
Thanks, Mike. That's a good start. I would recommend, I think, Maria, if you have a question now, it's your time to go. You're muted. Okay.
Yeah, thank you. I'm actually, it was full of details, so I stopped writing down my more detailed questions and tried to reflect upon the overall thing here. And something that strikes me as very interesting with its context of cities is that you end up in a socio-technical system, however you turn yourself. And I think all the different presentations today addressed that aspect, but in very different ways. And personally, I really like the socio-technical systems because they challenge me. But sometimes that can also be very frustrating. It can be inspiring by itself, but also frustrating. So I'm a little bit curious as to maybe one or two of you would like to respond to that out of the presenters. How did you find that kind of mix between things? Did you find it challenging? Because, you know, as I see it, if you mix social and technical systems, you have different types of data, you have different types of methods. And if you go to theoretical basis, you have different types of theoretical basis, you have to interview different types of people, you have to, you know, mix knowledges of different types. Did you find it mostly advantageous or disadvantages for your research, or challenging or inspiring? Any reflections on that from the presenters?
Maybe you want to direct that question to Tim to begin with.
Yeah.
What do you say, Tim?
Absolutely. Yeah, I think I start the morning sometimes hating STS, and then I end up in the afternoon when I make sense of things. I appreciate the challenge, and I think it is a continuous theme in my research design. I think one of the biggest issues has been trying to integrate, because obviously we have stakeholders that are in the frame, part of the project, but also the ones that are outside of it and not really, whose perspectives are not included, and trying to bring those in is one of our challenges, but as well as looking at the interactions within the project, both horizontal and vertical, and how those impact the outcomes, and what is the best way to engage those stakeholders together using these design methods. And I think that has been a reflection. For example, if we look at off-peak deliveries, it is a very provider-driven process. Most of the research has been done on the companies delivering goods and how do you deliver more sustainably. And the perspectives of the receivers have not been included that much, as when it comes to like the costs of operating at nighttime, or the complications with insurances and all of these things. So it is very important for us to try and balance out this knowledge gap that exists within the project, and also bring in those perspectives in our world building, or whatever designerly term we want to use for it. And I think the more we go towards data sharing, the more we go towards a highly complex technological aspects of the project, the more challenging it becomes to clearly see how we go about it. And I think that's when it is important to see these collaborations, because I think everyone today can see how our projects somehow touch and build on to each other, but it's not that clear. And I think that's also the challenge within the research community, and how we try to build on top of each other's work to overcome these more complex issues.
Yeah.
I hope that made sense.
Would it be fair, Maria and team, to say that finding a technical solution is only half the solution?
Absolutely.
I'd say it's only the start.
Yeah. So let's say, team, that I would come up with a fantastic data sharing system that Annette is providing or studying. How would you see that being received, or within the framework of the social aspect or collaborative aspect? What kind of things would pop up then?
I think we are looking into this framework where we are looking at how we would bring different stakeholders together and envision these futures. Something similar we already do with our different like agile workflows, or design thinking, whatever we might call it within HITS, but we want to do it through more in-depth, more long-term design experiments and design activities, in order to like create these visions of the future, but also include these perspectives early on. If we talk about, if you have this data sharing, this great data sharing platform or solution, but the providers don't really need it because it doesn't do much for their business plan, at the end of the day, it comes to whether the receiver gets value or not. And I think investing time and energy in creating a data sharing solution when there is no need is a waste of value as well. So it's.
Do you agree, Maria? Is that the conclusion?
Yeah, and I agree to a lot of things that you say, Tim. And I would also, if possible, I would like to direct the same question to Christina, because I think Christina is taking it. She's really adding this aspect of legislation to this. So it's business and legislation in a mix around the technology aspects.
Yeah. I was thinking about the question when you asked it, because in my previous life, well, lawyers in general, they never talk about technique. Actually, the criminal law and constitutional law, it's not about technique. But since I started at RISE is very much about innovation and new technique. We talk about this topic almost every day.
Yeah.
So to me, it was like, why doesn't lawyers think about this? Because it's very important. If you're regulating new technique, you need to understand the technique.
Yeah.
But lawyers in general, I don't know. maybe we are not interested in technique. I'm not sure.
Is it perhaps among patent attorneys and things like that?
Yeah.
They delve deep into technology aspects, but maybe not for the broader.
I would say so, yes.
Yeah. Okay.
Would that mean, Christina and Maria, do you think it could mean that technology moving forward can be challenged by legalization and policy being behind?
Or maybe if lawyers don't understand the technique, you will have a wrong legislation.
I get it. Okay.
Yeah, I would agree.
Okay. Thank you, Maria and Christina and Tim. I would like to.
Yeah, can I just add a little bit to that? There is, for example, a big ongoing discussion right now about the legislation around AI and machine learning, how we should handle that, specifically high-risk applications. So we are just in this situation right now in this sort of society, in legislation around Europe. How do sort of policymakers and lawmakers understand what AI is and put the sort of reasonable framework around it? So it's very interesting development going on right now.
All right, thank you. I would like to hand over the microphone to Sunk. Yeah, have you figured out some question you would like to ask the presenter?
Oh, yes, yeah, quite a few, but I would also like to start with thanking for the presentation and the work presented. Really interesting, and I got a lot of reflections here. And I could start with a few detailed questions, but I think I could take one which also leads to a more general questions for the whole project. And the one is to Jonas, actually. You recite about that the vehicle kilometers increase if you share passenger and freight operations in the system, which is somehow not really intuitive or counterintuitive, because you also presented the dummy example at the beginning, which shows that there are benefits. And I wonder if you have any interpretation why this is the case. Why do the vehicle kilometers increase? And if not, I have a hypothesis, which is maybe the urban form. That is, since you are within, I think, if I understand correctly, it's within the dense part of Stockholm. And if you have quite a lot of demand for both passenger and freight flows, then you don't need actually to share the vehicles because they may be efficient on their own if they are separated. That would be my interpretation. And this leads actually to the point which is more general. How do we include the urban form or the different densities we have in urban systems? This is also related to Claudia, but you presented, I think, since how to assess urban consolidation centers, for example, in Gamla Stan in Stockholm compared to Mall of Scandinavia or other malls in Södertörn or so. And also off-peak, for example, we know that they perform differently considering what kind of...
Two questions, Anki. Start with one then.
Yeah, great.
So start with your first question then to Jonas.
Yeah, okay, Jonas, why do the weekly kilometers increase? Very direct and clear question.
I was also surprised when I saw the results. I was basically reporting them as they came out of the optimizer. One question, I don't know if you saw it in the chat, was also targeting to that. The increase is not extremely much. So I checked just now the raw data. It's around 1 to 3%, depending very much on the scenario and the parameter settings. I agree that it could be because of the urban setting, that is a possible explanation. Mm-hmm. I have to say that there is not really a strong, like just from the concept of operating, I cannot really say that this is the case. It could be that the positions of the service depots are not in good places. Mm-hmm. So that means to exchange the module, the vehicle has to drive quite far, change the purpose, and then continue driving. And maybe it is overall beneficial to accept this long trip, because then you can reduce waiting times and so on. Of course, you could also reduce the waiting times in the same way by having another vehicle driving around and serving these customers, but that would then maybe be worse than just having one vehicle driving longer. So I think there is these kind of, I don't know, trade-offs happening, right? So that's, I think, and I don't know if this is enforced by urban environments necessarily. It could be. I have to say that's interesting to study. Yes, I think the scenarios, that's why I also try to have them quite different, have a high influence on the overall result and the conclusions we can make. Yeah. Yeah. I don't know. I think that was hopefully good answer for your first question.
I think Sönke's question is really good. I mean, you're really asking Sönke if a mixed mode operation scheme has situation when it's always beneficial, or situations where it's not always beneficial.
Yep.
And that would apply to freight and freight combinations as well as freight and people combinations, I guess.
Yep.
Yeah,
yep.
and based on what you answered now, I think it would be also interesting to see how the number and location, or you said location of the switching points, but also probably number. If you have a better coverage, then the distance to these changing points would also decrease, I guess. So that is probably also a relevant factor to consider.
Yeah, absolutely, absolutely. That's, I guess, what I said in the very fast in the end is one of the potential future directions which I'm looking into. First, how big should they be, right? So you also have a cost for them. If they're very large and have to be downtown, maybe it's not really a good idea to have them anyway, if the benefits are quite small. So that's something to investigate, certainly, yeah.
And Sönke, you had the second question, as I understood it, to Claudia.
Yeah, or maybe also to the whole project, to all of us. I mean, how do we consider the urban form? What are the solutions to which we look at? How suitable they are in different urban settings? I think that is a very relevant question. I sometimes I wonder, for example, urban consolidation centers, what kind of density you need in order for them to be competitive. So, and then the question would be, yeah, is it for Gamla Stan, but also for maybe Södermalm or Södertörn? So I think this is a question for the whole project, I think, which we should reflect on.
I think, Sönke, you and Sebastian are looking into that matter in a separate task that you're doing in the project with your simulation model, right?
Yeah, that's what we want to do, actually, yes, yeah.
So let's see how you come out from your own work with Sebastian on that topic. Maybe we can have it as part of the presentation next time. It'll be very interesting. I think we move back. I would like to have a second round from Michael starting, and then Maria, and then finally Sönke. Yeah. Michael, do you have another question you would bring up?
Yeah, thank you. Well, maybe I can this time be a bit more general in that sense, but I was involved in the gallery. I went on the gallery walk yesterday, and it made me think about a few things which I haven't been at the top of my mind, I suppose. And that was that sometimes when we create solutions in order to change something, or we create something new, the thing that we propose can be quite complicated to some extent. So it's a new thing, it has to be integrated, it has to be quite complicated. And I suppose one of the questions that struck me when I was listening to Jonas present was, this vehicle is quite sophisticated. You can switch these bodies around and it will be quite a special thing. And then I was imagining a world in which you have to make choices about this special thing. And on the other hand, you could have just a very simple van that does a normal thing. And if the van doesn't work or there's a problems over here, you have a much more simple sort of substitution effect. And then I was listening to Tim present, and I was thinking about the way that you can get permission to do something providing you have this vehicle that meets this standard and it has this quiet equipment fitted and it does this. So to some extent, I think there's something about complexity and fixedness in some of this, which is quite important in people being able to adopt things and change them. So that led in my mind to thinking about change. And I went back to the presentation from Annette when you pointed out that some things with the pilot project, you could see that some things could be overcome. So lack of trust and fear of competition, you had a tick against that in the checklist at the end, and the same with restriction of data location. And it struck me that when we want something to change, we have to see what the potential benefits are, and the benefits are very spread across the people involved in that, and that comes in all the presentations. The way the benefits are is very spread around. And so I think if I have a question, it's really about how do we do need to work out ways to communicate these potential benefits. And in some ways, in all of the presentations, there's a question about the potential benefits, whether it's Tim saying receivers don't see the benefit, or whether it's Annette saying the cultural and organizational barriers, we still don't see the benefit. And as Jonas saying, who gets the benefit here, the person on the vehicle or the person using the vehicle? And in Claudia's as well, the way that we do the evaluation will also show the benefits at the organization level or the other one. So I think the way that we explain benefits to people to encourage change is very important. And that's not exactly a question, but if anybody wants to comment on how they communicate these benefits, I'd be interested in that. And it was Annette's presentation that struck me about that. So if Annette had a comment about that, I'd be very happy to listen to it.
Well, thank you for the question. Yeah, thank you. Yeah, luckily, it is tricky, and it's very much about communication. And I myself come from a very technical field with the sort of the technical solutions, but it's important that we technical people see exactly what you say. That how do we communicate this and sort of communicate what's in it for them and what are the benefits, and are there true benefits, or are we just trying to sort of cheat people into this? But we have addressed this, and it's basically goes back to creating a good collaboration atmosphere where you spend time with people and engage them. I think that, and we have tried some of this. We've not solved it for all the cases. We have still ongoing dialogues within this project, but sitting down, seeing the other person on the other side and seeing what's in it for them, and seeing their fears and obstacles, and take that seriously, and from that move on and see what solutions can we then create. And I've seen this a lot within Scania for the last 15 years within data sharing, that some of these obstacles are really, it's more perceived fears and lack of communication or reaching each other. So yeah, that's really something we work with on, and maybe we technical people are not always the best to do that, but hopefully we can pair up with people that are better doing it.
But it comes in several of the ways that it's being presented. The sort of the winners and the losers, and the asymmetrical or not way of seeing that is very important in making change happen. So I think you have some that's another connection between all of the things that were presented. So thank you very much.
Yep, thank you.
Thanks.
Thank you, Michael. So Maria, would you like to pose another question?
Yes, I have to select one. It's very difficult. But in line with what Michael said, it's benefits and so on. I think the whole project is called Sustainable Integrated Urban Freight. And in some of your presentations, Claudia's, for instance, you addressed the sustainability concept as such in different ways, which was very interesting, I think. And Jonas and Tim, I think you also addressed, you didn't say so much about sustainability, but it was, you addressed the waiting time for people and so on, different sustainable things, and also the environmental side. But I would like to ask both Annette and Christina, for instance, I definitely see sustainability connections to your research, but do you address sustainability, or will you address sustainability as such directly in your research, and how do you think about that? So if one of you...
I can start that, yes. And I realized also a little bit the flaw of my presentation here. I did not address that specifically.
Have a short time.
Some of the use cases that we have identified applications are green benefits, environmental benefits. And we have actually worked with, I think we had in the end like 10, 11, 12 different sort of benefits that we have made a preliminary scoring on, for example, sustainability and novelty values and so on. So that is definitely
very small question on that, very specific, because sometimes we talk about the internet and the increased data use and data processing, and so it takes a lot of energy.
Yep.
Is that part of your analysis too, or is it? Maybe you can tell me. Is it very small, so we don't have to think about it? Context.
No, it's not part of my research. Yeah, I don't think it will be, but I know there's other interesting work elsewhere going on. So it's definitely an issue that society have to think about.
Yeah.
But I would probably not address that.
Okay.
Yeah, I don't see it as it's a cost more than perhaps a barrier right now, but it could be that. Yeah. But my perspective will be more to sort of what green benefits can environmental benefits can data sharing bring about. For example, I wrote in the chat here a discussion, a true environmental footprint per order or per package, or how do you schedule deliveries based on what is most environmental friendly, so to say. Yeah, so that is typically, but I didn't have such an example, and I realized that was my bad.
And I didn't read the chat, so that's my bad.
All right, people, I'd like to start wrapping up. I'm sorry. It's a very interesting discussion. I think a couple of final words from Maria, Sönke, and Michael on a question from me. I think it was posted in the chat, but I mean, the total project, the HITS, contains two quite significant parts. One is innovative approach, testing new things, piloting, etc., which generates new concepts. And then the other part, which is what we are listening to today, is try to evaluate things. And I think there was a question posed, how do we have help from researchers in evaluating potential benefits of new concepts? I think that was posed. Maria and Sönke and Michael, do you have any comment on that from your top of mind?
I think in terms of, I think we have a lot of times, sometimes industry or society is changing faster than researchers can write about it. And that's just one of those features of change, I think, that the rise, for example, of instant deliveries of food products happened before researchers start writing about that topic. It's talked about a little bit, yeah, and so on. But I think what we can do as researchers is that we have established techniques from different fields in all kinds of different ways, which can be applied in new ways. And I think that's what we see happening. So some of these things take lessons from the kind of approach of footprints and carbon life cycle analysis, for instance. And we look at that question just as Maria introduced it in the question of the information using up energy, and applying that allows us to address change and comment on it in different ways, which gives us insight, and then that insight can be used for policy formulation, or can be used to make decisions about yes or no or maybe about things. So it's a slightly woolly answer, but it's an attempt at saying yes, we can help.
Maria, what do you think?
Well, I think it's in line with what Mike say, a little bit different. I think researchers actually can help in expanding the space for the solution that is proposed or something like that. Because if you're on a company or organization, you have a solution in mind, you're very keen on it, and you tend a little bit to see the benefits. But I think we as researchers can contribute with a more neutral and more complex, to bring a wider understanding of things in line with what Mike said right now.
Good one. Okay, Sönke, a final word from you.
To make it short, I can agree with Mike and Maria, I would say. Maybe to add that I think it's the role of research trying to provide the stakeholders with data as well, and to see the connections between different gains and pains and so on, what we are actually trying to do in this project. I think that's very important for decision makers, if it's now industrial or from authorities, that they have better knowledge about what will happen if they do certain things. I think that's very important for us.
Okay, thank you, Sönke. So I think we wrap up this presentation now. I would like to see if Banna, would you like to say some final words and conclude, or should we just say thank you to all speakers?
Yes, I think I would like to say thanks to everybody who's joined us today. This was a new kind of format that we are trying out today, and I think it worked really well despite our initial hiccups. So I would just say that keep a lookout on our website and our socials, and you'll get updates for new seminars. Regarding this one, since we have recorded it, it'll take a little bit more time for us to put this together. But we will let you know soon enough when the video is done, and you'll get a link for that. And we'll also send out some feedback forms for all of our speakers and all of our participants. So hopefully you'll let us know how your experience was with the seminar today. Yeah, I think that's about it.
I'd like to say thank you to Thank you to Banna and the seminar team, and thank you to Michael, Sönke, and Maria, and thank you to all the speakers. Thanks for a great seminar, and have a nice weekend. See you all.
See you.
Thank you.
Thank you.
Thank you.
Bye-bye.
Nice to see
Thank
everybody.
you. Bye.
Bye-bye.
Thank you. Bye.